account for cos.
And that's how this lesson begins with the. So derivatives of trigonometric. Oh, and I need the calculator too. So derivatives of what is dy by dx if y equals sine x? Let's graph it and find out. So if you have a graphing calculator, you can pull it out. All right, so set the window on your calculator. So first of all, the mode, it should be in Radian mode, right? And it really should just default to that if it's been cleared any time in the last. So negative 2 pi, and pi day is Saturday or Sunday? What's today?
Saturday.
Okay, it's Saturday, yeah. So sorry, we can't celebrate pi day here. By pi is over 2. And y, so negative 2 to 2 by 1s. Okay, and we want y equals, so y1 is equal to sine of x, sine x, close parenthesis. And y2 is n derivative. That's really, so it's under the math menu, and it's number 8, n deriv. And then, you know, of course, depending on the firmware that you have, you're either looking at this. So we want d by dx of sine x. Now I can just type in y1, right? So I'm just going to go to vars, over to y vars. And the reason I'll do that is because then we can change y1 and, you know, whatever we don't have to change this. And we want x equals x here. Okay, so in other words, we're saying evaluate the derivative at x. Now we could say evaluate the derivative at, you know, pi over 2 or at 2 or some, you know, give it a value. And then it would figure out the value, right? You come up with a number, which would be the slope at that point, right? So your calculator does this kind of stuff. And then hit graph. So here's y1 in blue, because it's color. Right? And there's sun. I mean, now, and it said change y2 to be thick, but being as it's red, we don't need to. We can distinguish between them, unless you're red-blue colorblind, in which case this is the, yeah, and it's happening slowly. That's, wow, I mean, I thought this was pretty fast. I did defrag the hard drive and I got rid of all the stuff on there. I don't know if that's going to make a difference.
No, we just slow on the calculator.
Yeah, so it's actually a pretty good emulator then. Okay, what does that look like? The red graph. It's the cosine graph, right? So what is the equation for the graph produced by y2? Y equals cos of x. I guess we don't need parentheses around there, right? Just cos x. So prove that d by dx of sine x equals cos x using the definition of the derivative. And these two guys here, right? So we're going to use, all right, so it's the limit as h approaches 0. Now, sine of x plus h, right? Somewhere on your formula sheet, you've got this sine a plus b, right? Which I'll give you because I had to look it up too. So it's the sine of a plus b is sine a, so in this case sine x, cos b, so cos h, plus cos b, or sorry, cos a, so cos x, times sine b, which is sine h. So that's the expansion of this, and then minus sine x, right? And that's just this term here, all over h. So the idea is to see, hey, if we can get this, so we've got some of these guys, right? Like if I've got the limit as h approaches 0 of sine h over h, I know that's 1. If I've got the limit as h approaches 0 of cos h minus 1 over h, I know that's 0. And so we're just going to do a little manipulation on here to say it's the limit as h approaches 0. So I'm going to split this out. And the way I'm going to write it is sine x cos h minus sine x. Okay, you kind of see where this is going. Now, at this point, we'll be able to factor that out, right? Over h. So that's this guy and this guy. So I'm left with plus cos x sine h over h. Okay, and let's toss some square brackets around that, right? Because this was one expression whose limit I'm taking, and I'm doing the limit of, and I've split this out into a sum. Okay? So everybody's good, right? This is what we've done, right? We've just written, so we brought the two sine x's together, right? Why? Well, so we can factor that out. So that equals the limit as h approaches 0 of, okay, so I've got sine x times cos h minus 1. And you know what, let's just write this as an h. So let's split this out, you know, seeing as it's, so I factored the sine x out of the top, giving me cos h minus 1. And I'm just going to write the sine x by itself and put the h under here, right? But it's still multiplied together, so it's still the same expression. And then here, what are we going to write? Well, we're going to say cos x times sine h over h. I put brackets around it. Throw parentheses in. And so we can see, hey, look, I've got this expression, cos x minus 1 over x. Well, it's actually h's, and I've got this expression, right? Sine h over h, and this guy. Okay, so can I hit extend page? Yes. All right, so what is that? Well, it's the limit of, so it's the limit as h approaches 0 of sine x times the limit as h approaches 0 of cos h minus 1 over h plus, so all I'm doing now is just sort of distributing the limit through, right? I mean, just saying, we know from the limit properties, you know, that the limit of a product is the product of a limit, that the limit of a sum is the sum, so now I'm doing a plus, and I'm just going to do the same deal over here. Limit as h approaches 0 of cos x times the limit as h approaches 0 of sine h, I guess I don't need brackets, over h. Okay, so we take the limit of an expression, right, is the, this is a product, so it's the product of the limits, and this is the sum, so it's the sum of the two products of the limits. All right, what's the limit as h approaches 0 of sine x? No. Limit as h approaches 0 of sine x. So it's sine x, right? Who cares? It's a constant, right? Sine x is compared to the h. All right, all right. So this is sine x. What's the limit as h approaches 0 of cos h minus 1 over h?
0.
That's 0. So we get sine x times 0 plus, what's the limit as h approaches 0 of cos x? Cos x. And what's the limit as h approaches 0 of, whatever's left there, sine h over, it's 1.
Oh,
Do we please have Ms. Cornell, Mr. Gomez as
What? Okay, so limit is h approaches 0 of sine x is sine x. This limit is 0 plus limit of that is cos x. Limit of this is 1, and so ultimately this is equal to cos x. Woohoo, right? We just proved what we saw, right? We saw that, we asked the calculator, hey, give me sine x and give me the derivative of that. And we saw, hey, it's a cosine function. And now we proved that this is true, right? Using the definition of limit. Back to first principles, right? The limit is blah, blah, blah. What is dy by dx if y equals cos x? All right, so now all I have to do is restart my calculator. Is go into y equals and change that to cos, right? And since I used y1 here instead of putting cos there, then now all I got to do is hit graph. Okay, so in blue, we're going to see cos x. And in red, we're going to see the derivative. Which it actually has to compute, right? This is, I mean, for doing cos x, obviously, I don't know, you know, it's always interesting, like, how does the calculator do that? You know, how does it graph?
Expected this result.
No, it's not. It's unexpected. What is that function?
I don't know. I'm sure you must have seen some sign of it coming.
Some sign. But what? Show me another sign on the sign. It's a negative sign. It's negative sine x, right? So, I mean, sine, it should start here and go up, right? That would be sine x, but it's starting here and going down. Ah, so that's the negative of sine x. So y is equal to negative sine x. Prove that d by dx of cos x is equal to negative sine x using the def. So, now you should be able to do this, right? You're looking at doing the same deal, right? Now I will give you the expansion of cos A. Here, so let's do this. Equals the limit, so I can try and squeeze this in. So cos A plus cos B, I'll start you out there, is cos A, which in this case is x, cos B, which in this case is h, minus sine A, which in this case is x, sine B, which in this case. And I would say, don't confuse this with the hyperbolic cosine, but you don't know anything about that. So. But if / when you study the hyperbolics, it's actually cosh, C-O-S-H, is an actual function. Okay, it's called the hyperbolic cosine, but then you have to do cosh of something, which, anyway. Okay, so take that from there, split it out, right? Look up at the top right of the page. What am I aiming for? Can I get a sine h over h? Can I get a cos h minus 1? Where's their common factor? How am I going to manipulate this? Okay, and I'll give you a head start. It's all on the same page too, right? Yeah, it's on the same page. So you're actually just looking up and saying, all right, what are you doing here? So. So we're rearranging and factoring. Right. Then we're just going to straight out take the limit of each term. So here we've got cos x times minus so we've got cos x times 0 minus sine x times 1, which is minus sine x, right? The negative of sine x. Okay, and then you toss in a little QED, right? Okay, we good? So same idea, right? Which all goes back to the limits, which aren't on this page anymore. Right? Just all goes back to that idea, right? And splitting things out. What is dy by dx if y is equal to tan x? Let's graph it to see if we recognize the graph. Again, I don't know what the amount of time. So now all I got to do, right, because I just got to hit tan. Okay? Because again, we've set it up to just do the derivative of y1. Okay, so in blue, here comes 10. And in red, here comes the derivative of 10. Okay, do we recognize the graph? the red graph. Yeah, okay. Yes, the blue graph is tangent. The red graph. It's secant-ish. It's secant-like. But secant doesn't just go one way, right? Secant does. Yeah, squared. Yeah. Secant squared, he says with a questioning. So is it secant squared? All right, let's find out. Well, we can use the quotient rule, right? We know that tangent is sine over cos. So using the quotient rule, that is g of x, right, the denominator, times f prime of x. Okay, what's the derivative of sine? Sine is cos. Okay, so g of x, the denominator, times the derivative of the numerator, minus the numerator, times the derivative of the denominator. What's the derivative of cos x? Negative sine x, right? Just finish that. Negative sine x over the square of the denominator, right? Which we will write as cos squared x. Okay, so what do we got up top? Well, we got cos squared x minus negative, so plus sine squared x over cos squared x. What's cos squared plus sine squared? 1. So we have 1 over cos squared. What's 1 over cos squared? Secant squared. Remember, with the reciprocal trig functions, there's only one co per pair, right? So cosine must go with secant, because there's only one co per pair, right? And sine goes with cosecant, and cotangent goes with tangent, which are the only ones that really make sense, right? Why isn't the cosine? Right. So there, it's secant squared x. Cool, huh? Oh, in the summary. All right, so we need to know this. Derivative of sine is cos. Derivative of cos is negative sine. And the derivative of tangent is secant squared. What this means when you're doing problems is that there are so many variations of the way the thing can be written. Okay. So on a test, well, if it's multiple choice and you've got something there, you have to figure out, okay, how do I manipulate what I have to get one of these guys, right? But you kind of know what you're aiming for because you got 4 choices. If it's written response, it means we're going to accept a number of answers, right? So, examples involving primary trig functions. Remember, you may need to use the power rule, the product rule, the quotient rule, and the chain rule to find derivatives. Determine each of the following derivatives, write the derivative in an appropriate form. Okay, so d by d theta of the sine of 3 theta. So cos 3 theta, right? I mean, what do? You just take the derivative of the function, right? But that's not all. So cos 3 theta, and then what? Which rule are we going to use? Chain, product, quotient, chain, power, chain,
Product.
chain.
Can we use
Yeah, no, you can't use product.
force?
Use the force. May the
No, I mean,
force
it'd be
be
ruled like force.
Oh, well, sure, but that's just Alberta politics. So it's cos 3 theta times So it's the derivative of the outer function, which is the cosine of 3 theta, times the derivative of the inner function, which is 3 theta. What's the derivative of 3 theta with respect to theta? 3. Right, which we will then just write as 3 cos 3 theta. Okay. So we do have, you can think of it as u is equal to 3 theta, and it's, you know, but at some point you just need to really just start using the chain rule and say, okay, so we have the tan of. Now, if it were just x, then we would just go sec squared x, right? But we're going to use what? The chain rule. Okay, so what's the first thing? I need the derivative of the outer function, which is tan. Derivative of tan is sec squared. So it's the derivative of the outer function with respect to the inner function. So it's sec squared 2x minus pi times the derivative of the inner function, which is 2, which is equal to 2 times secant squared of 2x minus pi, which turns out to be equal to, and I'm not going to go into why, turns out to be the same as 2 times secant squared of 2x, right? And it just has to do with 2x minus pi. What's the word? What's the period of that? And then what are we doing with it? Well, it's got a period of pi, and then it's being moved over.
On a test, are we expected
No.
to be able
So 2 sec squared 2x minus pi is what I would expect from you.
Okay.
Okay? I don't expect you. But I mean, if somebody wrote that, it wouldn't be wrong. If you tried to write that and it was wrong, it would be wrong. That would be called shooting yourself in the foot, right? Which is sort of like taking it one step further because you're clever but wrong. So, yeah. The problem would be if this is what came out in the multiple choice answer, then you got to sit there and think about why is this equal to one of these 4 expressions, right? Okay. Sine theta, cos theta. Okay, you should be able to do that, right? I should let you do the others, but you know the rule. What rule? Product rule. Okay, so apply the product rule and do it productively. So there are variations of how you may choose to do the product rule, right? I mean, I just do it as the first function times the derivative of the second plus the second function times the derivative of the first, which means that what I write out should be the first function followed by the derivative of the second, then a plus sign, then the second function, and then the derivative of the first, right? That matches up. Yours could come out in a different order, right? You might go cos theta plus negative sine, theta sine. There's some variation, right? But I'm looking for some variation of this, right? You have to come up with those same 2 terms. Okay, so then what do we get? So multiplying together, I get negative sine squared theta plus cos squared theta. I'm preferring to write the positive term first, then minus on the second term, right? And then looking on the formula sheet, I can say, oh, that's the same as the cosine of 2 theta, right? Okay, now we give that to you on the formula sheet. You got that handy in front of you, right? And it could be, so it's multiple choice. You look for cos squared minus sine squared. There it is. Good, I'm happy. You look and you don't find it there, then you go to the formula sheet and say, what's the variation? Oh, there it is. It's cosine of 2 theta. Is that actually on your formula sheet?
Yeah.
Okay, excellent.
So is cos squared of theta minus sine squared theta acceptable, or do we need to take that final solution?
Yeah, so if it's written, so if that's a written cos squared minus sine squared, I think it's
Okay.
acceptable, right? I mean, what you're always looking for is when I'm doing multiple choice and I don't see the answer, right? There's a couple, either I got this totally wrong, okay, which is kind of nice, right? Because, I mean, at that point, you know you did something wrong. You can start to go back and look through it and say, okay, did I get a sign as in positive or negative out of place? Did I? Because that's generally what happens, right?
Yeah.
It's like there's some mechanical error at one little point, and, you know. Okay, d by d theta, d by d theta, the sine of cos of theta. Okay, which rule? Chain. Okay. Go. Apply the chain rule. So derivative of the outer function with respect to the inner function. Times the derivative of the inner function. And then, of course, this simplifies, right? That's it, right? Do not go cos squared theta. You could write negative sine theta cos of cos theta. Yeah. You could put any order. But let's go with this. You must put the negative sign first, as with any constants, right? Any number values, that should come first. Okay. What you really want to watch out for in multiple choice is the variant of the answer is that they've got the negative outside. You know, you've got a negative inside. They factored a negative out of some expression and put a negative sign in front. And so it's really the same. It's just you've got like a sine theta minus cos theta, and they've got a cos theta minus sine theta because they pulled the negative up front. Right? That's sort of the simplest of a variation of, yeah, I really do have it right, but this is the form I have. And if it's written, yeah, we'll take either. Okay. But I would like to see the negative moved out front, right? And then either order of that, cos of cos theta times sine theta, or sine theta times cos of cos theta. X squared cos x. Rule. Product. And chain as well, right? Isn't it? Or am I just messing with you? Actually, you know what? No, there is no chain, is there? All right. Okay, wait. First function. I said. That was me. What is? Oh, right. The Apple Watch presentation. No. Is it an iWatch? No, it's the Apple Watch, isn't it? The Apple Watch. It's not the iWatch. All right. So, how are you gonna write this?
Trying to swim.
So there's one possibility, right? I could just rearrange it so I'm writing the negative term afterwards, and then I can say, it's a common factor of what? You know, I can pull an x out and end up with x times 2 cos x minus x sine x.
First order subdivision.
Yeah, I think, you know. A lot of times, the reason I'm writing variations is it's in doing multiple choice, you're kind of saying, wow, what I have looks nothing like that, but wait a sec. Is it really one of these guys? All right, fire away. Right. What rule? Quotient. Everybody's favorite quotient, right? It's over this squared, and it's like, well, that's just like doing calculus. Just you might as well just keep hitting it. Right? Because all I'm going to do is just go home and pound away at it. Like seriously, really, the only way you can get any good at this is just to go pound away at a whole pile, right? Okay. It's just, and you know, make lots of mistakes. Well, I mean, you know, try not to. It's not bad if you make lots of mistakes, right? Because you basically just need to be able to, but fix it, focus, practice. In other words, do one and then check the answer. Okay, it's not the same answer than say, do I have a variation? Is there anything I can do to manipulate my answer to get their answer? If that's not the case, then okay, what did I do wrong, or did I? Right? And then go into the online answer book and look, remember, they're showing you full answers, right? So how did they do it then, right? Like, how did I choose to do it? How did they choose to do it? You could always kind of graph your answer and graph their answer and say, same graph, so they must be the same, right? Like, that's one thing I might try and do is, all right, I got an answer, they got an answer, are they the same? All right, well, I'll pop into decimals or my calculator, let's just graph these two expressions. Oh, okay, I'm looking at the same graph. So they are the same, I just need to do a manipulation. Or, they're not the same, I must have made a mistake. Anyways, how do I do this? Well, I do the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, which I believe is going to give me what? Minus cosine. Over the denominator
I don't know. It's
squared.
the final solution, but that's sine of theta plus 1 over.
Oh, that's wrong.
Yeah, see, I'm not sure how to simplify. I got sine squared theta plus cos squared theta minus sine theta over.
Wait, you got sine squared theta plus cos squared theta?
Just one.
Oh.
What is that?
It's one.
It's just 1. Okay, so what do we got then? We've got 1 minus sine theta over 1 minus sine theta quantity squared, which is equal to 1 over, let's do that down here. It's just 1 over 1 minus sine theta, right? You got one of these, and that takes out one of those, and that cancels and gives you a 1.
That's so easy, street, Danny.
Okay. Good? Yeah? Okay.
Yeah. Question?
Okay. Okay. Well, this is a fun one. So I'm just going with, all right, okay, what's the definition of sine cubed of something? Okay, it's really the sine of something cubed, right? And I do that just, it makes it a little easier to manipulate. Okay, what's my outer function? My outer function is cube something. So what's my derivative then, right? Well, then it's 3 times whatever happens to be in here squared. And what's the derivative of the inner function?
Like chain rule within chain rule.
Let's just chain rule within chain rule a couple of times. Okay, so here's my function rewritten. So here's the derivative of the outer, right? It's 3 times whatever's in there squared, times the derivative of the inner function, which is the sine of x plus 1 minus 2. So we're now applying chain rule again. So I do the derivative with respect to this, of sine, so the sine, sorry, derivative of sine with respect to, so it's the cos of. Now let's, okay, times the derivative of the inside function, which is the x plus 1 to the negative 2. So that's negative 2 times x plus 1 to the negative 3 times the derivative of the real inner function, which is the x plus 1, right, which is just a 1. Okay, phew. Let's put that all together. What do we got? So I got a 3 times negative 2, right? So negative 6. I've got this sine of x plus 1 to the negative 2 squared, sine of x plus 1 to the negative 2 squared. I've got the cos of x plus 1, cos of x plus 1 to the negative 2. And I've got this expression. I've already dealt with the negative 2, right? And I've just got this x plus 1 cubed stuck down on the bottom, right? Because it's an x plus 1 to the negative 3. So the constant is negative 6, right? We get 3 times negative 2. Then we've got the expression sine of x plus 1 to the negative 2 squared. And then the expression the cos of x plus 1 to the negative 2. Over x plus 1.
For the last, we have to put the
No.
x and negative on the bottom and just leave it to the.
Yes. Yeah. Yeah. If it's in there, I would really rather see it on the bottom, right? Because that's where it belongs, right? We really don't want to have a negative power.
So why not put cos of x plus 1 over the power of negative 2 on the bottom?
We could. So we could rewrite this as negative 6, 1 over sine of x plus 1 squared times cos of x. So that's a possibility too. So we could write negative 6, 1 over sine, 1 over.
But wouldn't the cos also be on the bottom of the denominator along with the x plus 1 cubed?
So then do those all belong down there? Oh wait. Yeah, the sine. Oh, okay. Yeah, so it's the sine of. Oh, hang on. No, it's the sine of 1 over x plus 1 squared. And the cos of 1 over x plus 1 squared.
Oh, okay.
Okay. Or sine squared 1 over x plus 1 and cos squared. Yeah. Variations. Good enough, right? And then moving this, because this is clearly. It makes marking so much fun, right? Because there's 4 or 5 or 6 potential variations of stuff. So, that means when we give you some, we're trying to stick with something that is just sort of, obviously you should use the quotient rule on this, and if you do, then you're more than likely going to come out with this. But that doesn't always happen. Derivative of sine to the 4th x tan x. Okay, so which rule? The product. And then, or within. To do sine to the 4th x, you're going to use chain. Yeah. Yep. Okay, the third.
Sorry,
Yeah. The cosine go away? Still cosine here. Cosine here. Still cosine here.
Like from cos x plus 1 to negative 2 times negative 2 x plus 1. Yeah,
Oh, wait. So that's squared, right? So that's sine squared. So that should be sine squared of 1 over x plus 1 squared. And that should be cos of 1 over x plus 1.
Wait, no, I see what he's talking about. So in the equation where you wrote it all out, that third bracket, the one beside there, should still have the cos of x because it's like the whole thing.
No. No, this is the derivative of this inside function.
Oh, okay.
Right?
Yeah.
So this is the derivative of sine of x plus 1,
yeah.
right? So there's 2 inner functions, right?
Yeah, okay.
There's the sine of something, which becomes cos of something, and then the something is also requiring chain rule.
Yeah. So
Just go with this.
What you were thinking about, right, Jacob? Could I at least get
Okay, so sine to the 4th x times tan x. So applying the product rule, right? It's f times g prime, or the first function times the derivative of the second. plus the second function times the derivative of the first, which is going to be 4 sine cubed x. Okay, so remember, sine is sine x to the fourth, right? So that's 4 sine cubed x, and then there's the inner function, right, which is sine x. And so that's going to give you cos x. Okay, and that's where we're starting. And from here now we manipulate. So what could we do? Well, I could go sine to the fourth x over cos squared x. Okay, so secant squared is 1 over cos squared. And I could go, let's put the 4 sine cubed x first, so 4 sine cubed x times, now let's put tan x, which is sine x over cos x, times cos x. Okay, so we're writing everything in terms of sine or cos. So secant squared becomes cos squared, 1 over cos squared. Tangent becomes sine over cos. And why? Well, okay, because, hey, if you've got this, then these guys cancel, right? Okay, now what? So I could go, what could I go? I could go, well, that's going to be 4 times sine to the fourth x, right? So 4 sine to the fourth x. I could go sine squared. So let's do this. Let's go sine squared x times sine squared x over cos squared x. Okay, so I'm splitting the sine to the fourth up. But I'm doing this because sine squared over cos squared is tan squared, right? So this can become 4 sine to the fourth x plus, sorry, it's not times, that's a plus, plus sine squared x tan squared x. At this point, you could factor a sine squared out of both of these. So it could become sine squared x, 4 sine squared x, plus tan squared x. Tan squared could be replaced by, what's tan squared? Is like 1 plus secant squared or something? So further manipulation, right? Let's whoops. If it's multiple choice, you got to find which one. Right? So let's just kind of look at it. Likely you're doing something like this. You're getting down to something like this. And before you do anything else, you're now looking, if it's multiple choice, you're now looking at what form is the answer in. Okay? Like, so do I see a secant in the answer? If I do, then I want to manipulate something to get a secant. So let's say we had 4 sine squared x plus sine squared x times sine squared x over cos squared x. So that's this, right? So let's say we've got that. Sorry, that's 4 sine to the fourth x. Okay, so we've got that line. Where can we take this from here? Well, we've got 4 sine to the fourth x. And we've got sine to the fourth x over cos squared x. Okay, which we actually kind of, maybe it's this line should have just come down to here, whatever. Okay, so that's sine to the fourth x. There's a plus sign, there's a plus sign there, right? Plus. So if we take out the sine to the fourth x, we've got 4 plus 1 over cos squared x, okay, which is sine to the fourth x and then 4 plus, and this will be secant squared. Okay, so again, the thing, if it's written response, I mean, if you're just writing this out, then stopping here or here. And if it's not, when you're at this point here, or a variation thereof, let's say this point here, what form is my answer? Do I see a secant squared? Okay, then I need to get a secant squared. How am I going to do that? Right, well, I need a 1 over cos squared. How am I going to do that, right? And so looking at this and just playing it out as to, okay, this is what it needs to become, and how am I going to make it do that? How will I make it dance to my tune?
Blackmail?
Yeah, there's always that. Doesn't work well on that. Determine the slope of the tangent line to the curve y equals the tan of sine 2 theta at theta equals pi over 2. So what do we have to work out? Derivative. So we need y prime, right? And we're going to use the chain rule. All right, so it's the derivative of the outer derivative of tangent, which is secant squared with respect to the inner function, which is the sine of 2 theta, times the derivative of the inner function. So now we're worried about sine 2 theta, right? Derivative of sine 2 theta is cos 2 theta. But sine 2 theta also has an inner function, which is 2 theta, and the derivative of 2 theta is 2. Okay, so if you're following us, we've had to use the chain law twice, right? So we've got the tangent of blah, so it's secant squared of blah, or u, right? So call that a u, times the derivative of u with respect to theta, which is cos of 2 theta. But wait, that inner function is not just theta, it's 2 theta, so then the 2. Okay, so how would we write that? Well, we'll just put it in order, right? So equals, put the 2 first, secant squared of sine 2 theta times the cos of 2 theta. Okay, so that's an expression for y prime. What do we want? We want y prime when? Yeah, sorry. Yeah. We want y prime when? Yeah, y prime, and let's say theta is equal to pi over 2. So that's 2 times secant squared of sine, okay, 2 theta, theta is pi over 2, sine of pi, times the cos of pi. Okay, so it's 2 times the secant squared. Okay, what's the sine of pi?
Zero.
0. And what's the cos of pi?
It doesn't matter.
Well, it doesn't matter if secant squared of 0 is, but it's not. What's the cos of pi? -1. What's the secant of 0? Yeah. So what's secant? 1 over cos. What's the cos of 0? 1. What's 1 squared? 1. So it's 2 times 1 times -1, which is -2. So 2 times 1 times -1 is -2. So it does matter, right? Because the secant of 0 isn't 0, in which case, yeah, it wouldn't matter, right? So one of these guys had evaluated to 0. It's a product of 3 things, right? If one of them had evaluated to 0 and not the one that was passing the 0 to the secant function, which does not evaluate to 0, right? Okay, so it really does matter that cos of pi is -1. That's what gives us the correct sign. And we get -2. Okay, one more, right? One more? Yes, one more. Must be on a different page. One more. Determine y prime if y equals the sine of 2x plus the sine of 2y. Oh, what are we going to do? It's not explicit, it's implicit, so there's a little bit of implicit. There's implicit implied here. Okay? I mean, sine of 2x is easy, right? It's just cos of 2x times 2.
Oh, no, there's a y in there.
Yeah, there's a y in there. Okay, so it's the derivative of a sum, which is the sum of the derivatives, and 2x. Yeah, okay, well, that's just cos of 2x times 2 plus, and that plus is there because it's the plus from above. It's not because we're using the product rule. It's this plus this, right? So, you know, just be able to follow. So the sine of 2y is cos of 2y times 2y prime, right? So we need this. That has to be done implicitly. So it's 2 times y prime, right? 2 times the derivative of y with respect to n, which is y prime. Okay. So, what order? It's always a... So let's go y prime minus 2 cos 2y y prime. So just moving that over. So we've got the y primes on the left is equal to 2 cos of 2x. Okay. Now keep in mind, what are we aiming for? I want y prime to be 0. All right, so let's get an expression for y prime. So y prime 1 minus 2 cos 2y is equal to 2 cos 2x. So y prime equals 2 cos 2x over 1 minus 2 cos 2y. So we want to, what do we want to find? Says, oh, write an expression for all the x coordinates where y prime is equal to 0. Okay, so we're going to set 2 cos of 2x over 1 minus 2 cos of 2y equal to 0. Right, we want y prime to be 0. So what does that mean?
2 cos of 2x must be equal to 0?
Yeah. So the numerator of the term on the left must be equal to 0. We don't, the denominator, as long as it's not 0, who cares, right? So we need 2 cos of 2x to equal 0. So we just solve that, right? Which means the cos of 2x is equal to 0. Right? Just divide both sides by 2. And I don't know how you guys solve that. We can let theta equal 2x and work out cos theta, and then replace the theta with a 2x, and then divide everything by 2. And sure. What do you got? Pi over 4 plus n pi over 2, where n belongs to the integers or something? When cosine 0, where pi over 2, 3 pi over 2? But we've got 2x is equal to that. So, well, I replaced the 2x with the theta and then worked out, because I know the cosine of, you know, if I'm working out the cosine of what is 0, I have to do it from 0 to 2 pi, right? So x is equal to, so we're just going to multiply by half. So pi over 4 and 3 pi over 4, and 2x has a period of pi, right? So this is what apart? Pi over 2 apart? So pi over 4 plus n pi over 2, where n belongs to the integers. I don't know, like that. Throw some brackets around there. I don't know. I've never done 30-1, but in pure 30 it's something along the lines of what we would do. Is that it? Yeah. Yay. 55 minutes later. Okay, so you need to do a bunch, right? Like, seriously, don't be sitting here playing cards. You need to work on this stuff.